my name is Tianyu, and today I will present my final project for GE-464 titled Wildfire Impact Analysis in Maui, Hawaii, using a Python script tool. This project focuses on automating wildfire impact mapping through ArcGIS Pro and Python. In August 2023, a wildfire in hit Maui, Hawaii, Lahaina suffered the most damage, with many buildings and community facilities destroyed. Because wildfires are becoming more common with climate change, we need tools that can help with fast damage assessment. GIS is a very useful technology for analyzing wildfire impacts and supporting recovery planning. This research is important for several reasons. First, wildfires are becoming more frequent and severe due to climate change. Second, Lahaina experienced major damage and needs strong recovery plans. With GIS, we can quickly study how the fire affected buildings, services, and the population. The project helps identify high-risk areas and supports budget decisions for rebuilding. It also shows how spatial data can help communities become safer after disasters. Previous study shows that GIS plays a key role in wildfire risk assessment and recovery. For example, Yangjing and Zhou use GIS to map wildfire risk zones in China. Their research shows that spatial analysis can support disaster management policies. USGS and FEMA studies also highlight how geospatial tools help assess wildfire damage and guide mitigation strategies. Together, these works help show that GIS is very effective for analyzing and managing wildfire impacts. For this project, I used 4 main datasets: the wildfire perimeter and building footprints and hospitals and the roads. All datasets were stored inside a single geodatabase for consistent processing. To prepare the data, I first reprojected all the layers into the same coordinate system. Next, I clipped all datasets to the Lahaina study area. I then cleaned unnecessary fields and checked geometry to ensure the inputs were ready for the Python tool. On this slide, I'm introducing the structure of my wildfire impact analysis tool. It is a custom Python script tool with 8 user-defined parameters, including wildfire parameter, buildings, hospitals, roads, wildfire buffer distance, and other distance. The parameters allow the tool to run flexibly on different data sets while keeping the workflows fully automated. This part of the script simply reads the input from the tool interface. The tool automatically collects the wildfire parameter, buildings, hospitals, and road data, along with user-defined buffer distance. I also set the output, workspace, and naming prefix, so every output is organized in the selected geodatabase. Here I show the first 2 major operations. The tool creates the wildfire buffer, for example, 1,000 meters, and then clips both buildings and hospitals to find the one located inside the impacted zone. These 2 steps automate the pro part of identifying damage or certain infrastructure. The slide shows the logic for identifying potential safe buildings. The tool first creates a search buffer around major roads, then select buildings that fall inside the road buffer but outside the wildfire zone. It helps locate structures that might serve as temporary shelters or safer evacuation areas. The final part of the script generates a summary table. It counts impacted hospitals, impacted buildings, and safe buildings, and writes everything into a clean output table. This gives users an instant overview of Wi-Fi impact without manually checking each layer. And this slide shows the tool running. After selecting all inputs and distance, I click Run. On the right, the message confirms each step, buffering, clipping, selecting the safe buildings, and creating the summary. The tool finishes in about 24 seconds and reports all final counts automatically. Here you can see all the output features classes generated by my tool. They include the wildfire buffer and impacted hospitals, impacted buildings, road buffers, safe buildings, and the summary table. When I added them to the map, the spatial patterns become very clear, especially how the burn area overlaps with buildings and health facilities. This is the final map created from the tool outputs. On the left is Lahana showing the 1 kilometer Wi-Fi buffer and all impacted buildings and hospitals. On the right are the additional burned area across Maui Island. Together, the map demonstrate how the script tool helps quickly visualize wildfire impacts and support emergency planning. The results shows the significant wildfire impact in Lahana. The tool identifies 3,647 buildings inside the wildfire zone. 7 hospitals or health-related facilities were also located within the impacted area. In addition, the tool identified more than 3,800 buildings within 300 meters of major roads, meaning they could potentially be used as temporary shelters or supported locations. In conclusion, this project demonstrates how Python scripting can really improve the efficiency of Wi-Fi impact analysis, automating the workflow, reduce processing time, and ensures consistent results. The tool is reusable and can be applied to future Wi-Fi events or even other types of disasters. Through this project, I also gained valuable experience in writing Python scripts, managing geodatabase, and debugging geoprocessing tools. Okay, thank you for listening. Bye.